Hello people, so today we list on LeetCode equation 1579, that is to remove maximum number of edges to keep graph fully traversable. And in this, Alice and Bob have an n-directed graph of n nodes and three types of edges, and the types are type 1 can be traversed by Alice only, the type 2 of the edge can be traversed by Bob only, and type 3, edges of type 3, it can be traversed by both Alice and Bob. Okay, and we'll be giving an edges where edges of I represent type I, UI, VI, which represents a bidirectional edge of type I between node UI and VI. Okay, and we have to find the maximum number of edges we can remove so that after removing the edges, the graph can still be fully traversed by both Alice and Bob. And if that means if starting from any node, they can reach all other nodes. Okay? And we have to return the maximum number of edges that we can remove, or we have to return minus one if it's not possible. For example, in this we are having this. The red color represents the graph, the edge that can be traversed by Alice. Green represents that edge that can be traversed by Bob, and blue represents the edge that can be traversed by both. Okay. So for this, what we can do is we can remove the edges as of this edge, and we can also remove this edge, and still it will be traversable by both of them, because let's say if we are having four, Alice can go here and then he can reach here, then he can reach here. Similarly, the Bob can start from 3, he can go to 4 or 3 2 1. Okay, so that's why the maximum number of edges that I can remove is 2. And this is the union find question. So first we'll be doing is we'll be having a union find for both Alice and Bob. Let's just declare, and I will be writing the class first. That will be equal to union find, and here, okay, and in this we'll be passing n. So I'll just now copy and paste. Yeah, and now let's name it Bob, and let's quickly write this class. And this will be your class union find. Okay, and in this, what we'll be having is we'll be having three things basically, and array of representatives, and components, comp size, let's say component size, and then and components. Okay. Now when we'll be called the constructor and then find, and here I'll be having n. I'll be declaring this that comp is equal to n, representatives is equal to of size new int n plus 1, and similarly here I'll be having a comp size of size I n plus 1. Okay, and then here I'll be also adding updating these two arrays, so that for int I equal to 0, I less than n, I equal okay, I equal to 0, I less than n, I plus plus, what I'll be doing is I'll be doing rep of I equal to y, representative of I is equal to y, and here comp size of I is equal to I. Okay, and now what I'll be having to do is I'll be having to find write a function that is find representative for that particular node. Okay, then let's write this function as well. This will be a public and find representative. Let's call it find reps. Reps will be fine. Okay, and here I'll be having an int x. So then I'll be saying that if my reps of x is equal to x, I have to return my x, else I'll be calling the function of return reps of x equal to the find rep function, find rep one representative for x. Okay, yeah. Now I'll have to also write a function that will be public again, which is find union public and perform union. Let's say perform union to check if those two graphs are of these two paths are valid or not, like if they fall in the same set or not. So for that I'm having two nodes x and y. In x I'll be updating it with the find reps function, find reps of x, and y I'll be updating it with okay, and y I'll be updating it with find reps of y. Okay. Now what I'll have to check is I'll be saying that if x x is equal to y. I have to return 0 in this case because it's not possible. Then what I'll be doing that if comp size of x is greater than comp size of y. Okay, in this case, what I'll be doing is I'll be updating comp size of x by comp size of y, and also I'll be I'll be changing changing I don't know what the yeah, representative of y will be equal to x. Okay, else if this is not the case, in that case what I'll be doing is I'll be updating my comps of y, comp size y plus equal to comp size of x, and then I'll have to change the representative of x, which will be equal to y. Okay, and then what I'll be doing is I'll be doing a comps minus minus, that means the remaining components, and at the end I'll return 1. Okay, and now let's write a function that if it's connected or not. If the two I went out of the class. Yeah, public boolean, like at the end I'll be saying that if the two if the graph that I formed is still connected or not. So for that case, the number of left components will be equal to 1. Return comp equal to 1. Okay, because if it's valid, that means that it's the whole component as 1. Now let's quickly write the rest of the logic here. Now what I'll have to do is, now let's have int edges required, which are the minimum edges required, that is initially 0. Now what I'll be doing is that for int edge in edges, what I'll be doing is that if edge 0 is of type 3, in that case I know that both of them can traverse, so in that case I'll be updating it by edges. No, I'll be updating edges required. What? Yeah, edges required by what I'll be doing is I'll be doing alice dot find it's perform union for edge 1 and edge 2. Okay, or I'll be performing it for Bob dot perform union for edge 1 comma edge 2. Okay, so this will provide me with the result. Now this is the case where I'm having edges as like the type of the edges 3. Now for the rest of the cases I'll be doing like for int edge uh, int edge and edges edges. What I'll be doing is that I'll be doing that if edge of 0 is of type 1, if edge of 0 is of type 1, in that case I'll be updating my edges required by uh, alice dot perform union of edge 1 and edge 2. Else if I'll be having to check that if edge of 0 is equal to 2, in that case I'll be using it to perform a union of Bob. It's required for Bob dot perform union h1 h2. Okay, and now what I'll be doing is and then I'll be saying that if alice dot is connected and Bob is also connected, Bob dot is connected. Okay, and that case I have to return the edges dot length minus edges required, that will be giving me the maximum number of edges that I can remove. Okay, else I have to return -1. Okay, now let's run it. It was a long video, definitely it was, and I knew it would happen. Okay, now let's have a look where this says that issue that has happened. Let's on the line 48, if rep x equal to find rep. Okay, find representative, that means if representative of x Okay, here it should be instead reps of it. Yeah, now let's give it a run. Yeah, it gets accepted. Now let's submit it. And it works perfectly fine. Okay, so this has to be done. Thank you for watching.